Assalamu alaikum and good morning, everyone. Hope you're all doing okay. I'm really sorry for the inconvenience because Windows decided to take an update, though I checked last night, there was no update. So, yeah. But our class today will be short, a bit short. We have a few things to cover, so inshallah it will be fine. So before I start today's class, I like to ask you two things first. First of all, Levi, you asked about the slides. Did you get the slide? Because the slides are posted along with the video links.
Yes, sir, I got it.
Okay, so if you found something and there is a conversation going on about that thing, it is better if you reply. Because if you do not reply, I would like today, I have to ask you to ensure that you have got it. I'm not obliged to continue the conversation, but since all of you are beginner, I'm trying to be as much as helpful as possible. So if some conversation or some kind of dealing is done, remember to always close it. Okay, that you asked where you couldn't find the
Okay, sir.
slide. That's why I said to look for it there. So reply that you have got it.
Okay, sir.
Okay. One more thing that inshallah IIT is going to take ACM specific classes, programming contest specific classes from this Wednesday. I think they have told me about it. So those classes will be taken by your seniors, not only those who are in IIT, maybe are those who have already graduated from IIT, and you will get official notice. I mean, I will most probably I will post it about it in the classroom, so you will get information about that. So all of you, I would encourage you to join there, at least initially join there, see what that thing is, and that thing can actually, for those who are a bit weak, they will also try to take care of you, teach you the basics of programming, and then teach you how to use those things in something called competitive programming. So it's more like where problems are given to you, where you need to think logically, algorithmically, and try to solve those problems. So you will they can introduce themselves better than I can do. So once the time comes, I will let you know about it, and I would like to go there. I like you to go there, and especially uh, Tanvir Hossein Dihan. I'll definitely ask you to go there. Okay.
Okay, sir.
Anyway, so let us begin today's class. Okay. Before, okay, I almost forgot that I need to share my screen. Time to start recording. So, anyways, I think the slide is visible. So, our today's topic is expressions. So, our today's topic is expressions. Okay, there are too many topics. We're not going to cover all of these today. We're going to cover up to precedence and associativity today, and next of the topics will be covered in the next class. So this is the topic for the whole week. So first of all, what are expressions? So you people are familiar with expressions, like in algebra. You can see something like this. This is very common. Evaluate x plus 3, or evaluate x plus 3 plus y 2y, or something like that, where the values of x and y are given. And the expressions are basically relations between variables, constants, using some kind of operators that can be evaluated to a value. That's an expression. It consists of variables, constants, and operators, and it evaluates to a value. So actually, these kind of assignments are also expressions in C, but we will check them out in the next class, how they're actually expressions. For now, we can simply calculate the area of a circle as pi into r square, right? If the value of r, if the value of pi is given, then pi into r, or pi into r square, evaluates to these values. So whenever in these slides I am using the arrow sign, think of them as some expression being evaluated. Okay, they are not part of programming, but for the purpose of this slides, the arrow symbol means that those values are getting evaluated. So 12.5664 is the area of this circle. This expression evaluates to this value. Okay, so operators are closely related with expressions, right? Since we use them to make expressions. So operators work on operands, the things that operators actually do work on, and produce values. And they are building blocks for expressions. So C has over like 50 operators, and there are many different kinds. For today, we are going to take a look at arithmetic operators, mainly arithmetic operators today. And we are going to take a look at assignment operators in the next class. Arithmetic operators, assignment operators. Relational operators are like to express those are used to express conditions in programming language, like if your age is greater than 18, then let's say you are eligible to vote. Age is greater than 18. So I'm saying age is greater than 18. Also, logical operators. Logical operators are used to bind such two conditions. So, in order to vote in Bangladesh, not only your age needs to be greater than 18, you also need something else. What? Your nationality needs to be Bangladeshi. So, if, or you need to be, yeah, you need to be a citizen of Bangladesh. So, we can say it like this. If your age is greater than 18 and that and is a logical operator, logical and, this symbol is used. We'll take a look at the letter and you are a citizen of Bangladesh. That is, your citizenship is equal to is completely equal to Bangladeshi. That's relational operator. Then you can vote. And then we have bitwise operators. You will be taught about like binary, octal, hexadecimal, these number systems in like fundamentals of computing or introduction to computer, whatever that course is. The name of the course is. So basically the intro course. There you will be taught about number systems. So you will know about bits. So once you know about bits, you can also take a look at what bitwise operators do. And there are some other operators which actually does not look like conventional operators that we always use, but sometimes something like printf, another function, can also be considered as an operator in C. So there are other operators like size of. Okay, so reference, the word is not used here, only this thing is here used, reference, dereference, asterisk mark. So we'll take a look at that later. You will most probably take a look at this after the mid exam. Anyways, so in order to understand what an operator does and how an operator performs some operation, we need to basically understand just three things. Understanding three things about an operator will give you every insight you need to solve any expression using those operator. First one is the precedence. Precedence means the priority of an operator. How? In our like algebra or general arithmetic, we follow a rule like Bodmer's rule, right? Brackets, and then those are like multiplication is always done before addition. Division is done before addition and subtraction. Relationship like those. Even in a programming language, there are those precedences. Okay, so this operator in a large expression containing multiple operators, this operator will be evaluated before that one. That's the precedence. Associativity. So this is like the grouping of operators. Each operator works on some operands and it needs to group those operands together to work there. So how the operator groups their operands or how the associativity work, we'll check when we go there. And finally, yeah, definitely operand type and operations. Each of the operator works on some specific type of operands, like some works on integers, some works on floats, some might be mix of them, and there are definitely other data types which we look at later in C. So operators work on operand and perform some operation. So if we know which type of operands they work on and what operation it performs, for instance, we know that the plus operator works on two numbers, and what they do, they add the numbers together. So if we know that, okay, plus operator works on numbers and it adds them together, we can solve like 1 plus 2, 1.5 plus 2.223, this kind of equation or expressions. Okay, so today, this is our main topic. Today, we're going to take a look at arithmetic operators. Any question till now? Okay, it is fine. Okay, so yeah, there are like main five arithmetic operators in C. Those are addition, subtraction, multiplication, division, and remainder. I'm pretty sure as a student of science, you are familiar with the first four operators and you have seen them. Remember, multiplication is always written using the asterisk symbol in a programming language. These four, you are familiar with their operation. Remainder one, you have, this is the percentage sign, but in programming language, they do not calculate the percentage. Instead, they calculate the remainder of a division. We'll go there. So there are two types of arithmetic operators. One is unary, second one is binary. So it depends on how many operands they work on. So if we take a look at an operator, so like this plus operator, so each operator can at max work on generally two operands, right? So this plus works with this 3 and 2. If I write even a simpler equation, like 3 plus 2, or yeah, 3 plus 2, this plus operator is taking in two operands, this 3 and this 2. So this is working on two operands, and the result will be produced using the addition of these two operands. So this is a binary operation. Bi means 2. So 3 plus 2 is equal to 5. Instead of writing equal, I'll use this symbol for now. Okay. And there are some operators which actually work on a single operand. How? It's very common for us to like something like this. Minus 2 plus 5 is equal to 3. So this minus 2. Actually, it is actually binded with these two, and it is related to these two. It doesn't need any kind of operand before this 2. So minus 2. This minus is called an unary minus. So this minus is something like this. Minus 2 plus 5 equals to 3. So since this minus is working on a single operand, this minus is called a unary operator. So unary, the first part of unary, uni or something like that, it means 1, single, and binary, bi means 2. So 1 and 2. So unary operators work on single operand. Like we generally have two unary arithmetic operators, unary minus, and if you want to impose something like unary plus. So that's the unary operators, and binary operators are like addition, subtraction, multiplication, division. Okay. So yeah, these are the arithmetic operators. For this whole slide, I will call the unary plus and unary minus as u plus and u minus. Why I'm using the term u plus and u minus to represent unary? Yeah, it represents unary. And also at the end of 4th year, when you go into a course called compiler designs, and where you will see that how to make a compiler, like for C language, you know why these things are, why this naming convention, though they're called as u plus u minus. So anyway, forget about this one. This is the addition, subtraction, multiplication, division, remainder. Now let's take a look at all of those. Unary plus basically does nothing but to emphasize that number is positive. Integer I is equal to plus 10. We are like telling the reader here, it has nothing to do with the compiler actually. It just makes it positive. Yeah, this is a positive number. Actually, like in original KNRC, there was no unary plus operator. And finally, then there's unary minus operator. It indicates that a number is negative. And these things, arithmetic operators work with integer, floats, and there are other data types like even characters, doubles. So yeah, those things will come later. Indicates that a number is negative. So if float j is equal to minus 12.3, j is minus 12.3. Okay, fine. So addition, subtraction, and multiplication, the binary operators, these three works exactly like general mathematics as you would expect them to work. Like 1 plus 2 is 3.5 plus 2.5 is 4, exactly like this. So integer I is equal to 5, 5 plus 10, so j will be evaluated as 5. 5 into 12 is 60, it's fine. They can also work with single float, double float, it's fine, 5.25. 5 divided by 2.5 is 2.0, it's 5. Mixing type is allowed with arithmetic operators, and if you want to know what would be the resulting types, they are exactly as below. Remember, integer, this op will be replaced by some kind of operator like addition, subtraction, multiplication. It can also be division, we'll take a look at it later, or remainder. Integer, operator, integer. So integer plus integer produce another integer. Integer, operator, float. Integer and float, if two of them are in a expression with an operator, they will be evaluated to a float, integer and float. Remember, for the initial labs, I have given you like just simple notes that how they would work, but this is the real thing. And float with operator with another float will produce a float. And for now, let us just take a look at the division operator. So what the division operator will do, it's kind of like the general mathematics. If you're working with a float, that means if you write something like this, when I say working with a float, remember, we will try to follow this thing. Like if I say working with float, it means these two. That means it can be an operation between integer or a float, or between two floats. So if I write something like this, 15.5 divided by, okay, make it simple so that I can even calculate. Like 15.5 divided by 2.5, it will be evaluated to 6.0. And even if I wrote something like this, 15 divided by 2.4 is still be evaluated to 6.0 as a float. And if it is something like this, 15.0 divided by 2, it will still be evaluated to a float and it will be 7.5. So it is completely fine. However, the problem or the different behavior arises when I write something like this: 15 divided by 2. That is an integer being divided by another integer. So what would be the value? It will not be 7.5, it will be 7. How does it work? Yes, 5 divided by 2 actually produces 2, not 2.5. So you can think of this as the quotient of the division, of integer division. That means the result is always truncated to an integer. That means the fractional part will always be discarded. So even if the result is something like 2.99999 or many nines, it will be 2, not 3. It is not rounding, it is truncation. It's just truncating the result. Remember, rounding means if it is like 2.6 and you want to round it, it will become 3. But if you truncate it, that's the rounding. And if you truncate it, it will become actually 2, the lowest integer. So that's the difference between truncating and rounding. And the remainder, so if we get the quotient from here, so what do we do with the remainder? Well, there is an operator for calculating remainder in C, and that's the remainder operator with the percentage. Simple. So remember, division can also work with integer or integer float, that's fine. But remember, remainder only works with 2 integer operands. If you give any float, any one of them as float, like if you write 5 remainder, or we can call it more, 2.5, it will not work, it will throw you an error. So can we calculate remainder using floating point number? Yes, there are functions to calculate that. We will take a look at it later. Anyways, so, or you can also write your own. Okay, I might ask you to write your own later. Okay, so remainder works with 2 integers operands only, remember that, and it produces the remainder of this division. So if we want to find the remainder of division between 24 and 7, it would be 3. Why? 3 times 7 is 21, and 24 minus 21 is 3. So the remainder is 3. If you want to find the remainder of like 9, remainder 7, of the division of the remainder of the division between 9 and 7, the result would be 2. So it is as simple as this. So yeah, what will happen if we want to work with negative values? Now I said that when dividing 2 integers, the result is always truncated. In case of, if I do some divisions like this, like -9 divided by 7. So what would be the divisional result of the integer, right? So we can do it like this. If I multiply 7 with -1, so we get -7. If I multiply 7 with -2, we get -14. Our target is -9, right? We are familiar with how positive division between positive integer works. This should be division. This should be division. We are familiar with how division with positive integers work. We have always been familiar with that from our school life. But what will happen if we are saying that the result is truncated from negative number? Well, we can say that the result is between these two. It is between -1 and -2. That means it will be one of them. It will be either be -1 or it will either be -2. This is -9 is between -7 and -4. Remember this concept? This concept is really helpful. This type of concept, that when you try to narrow down a result between 2 numbers, it can be among those 2 or it can be between these 2. This kind of concept is important for further mathematics that you will do, or for even in research purposes. Anyways, so we know that it's either -1 or -2. So what will be the result? Well, in C99, the standard is set and it will always be truncated towards 0. Remember, towards zero. Truncated towards zero. That means which one of these is closer to zero? Minus one or minus two? The result is minus one, since minus one is closer to zero. So this value will be minus one instead of being minus two. However, had it been the C89 standard, I do not teach you much about C89 standard because it is almost obsolete now and not used anywhere, but still, that is implementation dependent. That means it's up to the compiler and it's up to the machine how it will work. Why is it implementation dependent? Well, because different computers have different chips, different processors, different systems, and even on the operating, depending on the operating systems, they might behave differently. So, if it is implementation dependent, it is left up to the people who develop the compiler to figure out what will be the fastest and best for that PC. And since our PCs have improved quite a lot, our computers, so that's why C99 has set the standard that it will always be truncated towards zero. So if I write something like this, minus 16 divided by like 3. So can anyone tell me what would be the result? Minus 16 divided by 3.
Minus 5,
Nice. And why isn't it minus 6?
because it is truncated towards 0. Minus 5 is closer towards 0 than minus 6.
Exactly. Nice. Very nice answer. Okay. So that's why it will be minus 5. So what will happen if I write minus 16 divided by minus 3? What would be the answer?
It is still minus 5.
Exactly. It is still minus 5. Okay. So now, as we have already dealt with negative numbers in division, let us talk about the remainder operator. So how do we deal with negative numbers in remainder operators? It's simple. Just look at the first number, see its sign, and put it there. Do the calculation with normal numbers. Take the sign of the first number or the left operand and stick it before the result. That will work. That means if we want to find the remainder of like 16 of remainder of 3, it will produce. What's the answer of 16 remainder of 3 or 16 mod 3?
So 1.
Okay, 1. So minus 16 remainder of 3.
Minus 1.
Hmm?
Minus 1.
Minus 1. Minus 1. It will always take the sign of the first symbol. What's the result of 16 remainder minus 3?
1.
1. Nice. And minus 16 remainder minus 3. What will be the result?
Minus 1.
Nice. So all of you know how remainder operator works. Okay. Okay. So that's what I have planned to cover up today. Oh, sorry, no, precedence and associativity is also included in today's class. Sorry. Okay, so we have already talked that we need to know 3 things in order for us to know how an operator behaves. Sorry, let me just need my phone. Sorry for the inconvenience. Okay. What are the things that we need to
Sir,
know?
I have a question.
Yeah, sure, go on.
Sir, if we divide 5 by 2 and we want the answer to be 2.5, what we have to do?
Okay, so if I divide 5 by 2, nice question. 5 by 2, we want the answer to be 2.5, but we cannot get 2.5, right? So let us actually take a look. Let me write problem. You can see this, right? Okay, so I want the answer to be 2.5. What will do? So can anyone tell me, just like logically, in order for it to be 2.5, what would have been the condition so that this value 5 divided by 2 evaluates to 2.5 by
Sir,
imposing what? Yes.
it needs to be a float.
Okay, so what needs to be a float?
Sir, one of them, 5 or 2
The
needs to
output
be
value.
float.
Yes,
Percentage.
at least one of them needs to be float, right?
Yes, sir.
Okay, one of them needs to be float. So there are like two tricks or multiple of them actually. Like we can convert 5 to like 5.0 and it will work, right? So we can to print it like it's %f, sorry. It's 2.5. Or I can also convert the 2 to 2.0. It would produce the same results. That would be 2.5. Let's take a look. We have time, so why not take a look at it. It's still 2.5. Or both of them can be floats and it will still be evaluated to 2.5. Okay. But it's not like we are always writing them as float, right? It can be like already in an integer variable. So new divided by deno. So how do we like make it a float then, right? There's something called typecasting where we can actually ask the compiler to convert one type to another and do the calculation. We can do simple typecasting by writing the type that you want before that in bracket. It is also an operator like this. So in this case, I'm just asking that, okay, make the numerator float. And now that numerator is a float and we're dividing it by another float, another integer, float divided by integer, float and integer, the output will be, if I hover over it, it should say float. Anyways. 2.5. This is called typecasting. Also, when I like doing an operation between integer and float, and the integer gets promoted to a float, it's called type promotion. There are a lot of type promotions in C. Since there are a lot of types in C, whenever you're doing operations between two non-matching types, they are actually some of them are promoted to another type, and it's called type promotion. We might take a look at type promotion later. Anyways, so this is called typecasting. You could also have casted this denom to float, or anything. And if you do not want to do typecasting for some reason, you can do one more cheating. That's like plus 0.0. So can anyone tell me why would this work? Anyone?
Integer plus float equals to float.
Yes. And so this, so you like, just like mathematics, you would evaluate equations or expressions step by step even in C. So numerator plus 0.0. This is an operation between an integer and a float. So the overall evaluation of this statement would be a float. This would be a float. And then we'll do a float divided by an integer, and the operation will be done in float, and final output will be a float as well. Okay. So these are the two tricks that you can apply to convert integers to float if you are working with pure integer, calculating pure integer. However, these situations should not generally occur because whenever you are like taking input of two numbers and you want you want the fractional part, the number themselves should be taken as floats as input, not as integer in most of the cases. Okay, so satisfied with your answer? Satisfied with the answer? The person who asked the question?
Yes, sir. Thank you, sir.
Welcome. Okay. Now, I have said before that we need to know about three things to understand how an operator works. Those are the precedence, associativity, and finally, what the operator does and what type of operand it works on. We have already taken a look for some of the operators, what type of operators it works on, like the arithmetic operators, and what operation they perform. Okay. So, precedence, the order of evaluation of an operator. That means higher precedence. An operator that there is a precedence table. An operator that has higher precedence will be evaluated before an operator that has lower precedence. So if I write a simple mathematical equation like this, 3 into 4 plus 5. So can anyone tell me what would 3 into 4 plus 5 will be evaluated to? It's a silly question.
17.
Okay. So why is it not like 27? Why is it 17? I mean, if I
So multiplication will be done at first, then summation, sir.
yes, so multiplication comes before addition, right? So that's the rule of mathematics. So like 4 plus 5 is 9, then 3 into 9 is 27. That's wrong. So 3 into 4 is 12, and then plus 5 is equal to 17. So that's the rule of mathematics. Similarly, similar rules are imposed in programming language, and that's called the precedence. That means anything with higher precedence will be evaluated first. Multiplication has higher precedence than addition. So again, just like mathematics, operations inside brackets are done first, just like general mathematics. So from now on in the slide, we will like these two expressions are equivalent, and we will use brackets to show you that which one will be evaluated first. So similar way, 1 plus j into k. So j into k will be evaluated first. So these two are equivalent. We use the bracket just to show that, okay, this is the form. So what about unary minus or unary plus? We evaluate the minus numbers themselves before, right? Like if I write minus 3 plus, so minus 3 into minus 4, or let's just say minus 3 plus minus 4, what will this thing be evaluated to? So generally you put a bracket like this, right? So this is more like minus 1 into 3 and minus 1 into 4. So this thing will be evaluated first. 3 with a minus makes it minus 3. 4 with a minus makes it minus 4. Minus 3 plus minus 4 will be minus 7. Okay, that's how these things are evaluated. And yes.
Will the program show error if we do not put the brackets?
No. This is just to show you guys. It will be fine.
Okay, sir.
You know what? Actually, this would also work just fine. Want to see? Let's show you too. I think I forgot to give it one more than necessary. Or more than this will work. Okay. Yeah, that's right. I have faced some presentation, but if I want to put minuses, more minuses using like, okay, this will work fine. Sometimes some compilers will work and some compilers doesn't. If I put 2 minus, okay, now, oh yes, now this one is actually ambiguous, that whether this is an unary minus or binary minus, sorry, yeah, it doesn't know. So because since its next operand is a plus, its right operand is another minus, so it doesn't know what kind of operator this is. So, yeah. And do it like this, like minus plus minus, this will work. Yeah. Now it knows that, yeah, like I can stack as much plus minus I want. So don't get confused by this. You will understand the true behavior when you design your own compiler in compiler design. At least I'm pretty sure you make a calculator, simple calculator that does these type of things, and there you will understand. For now, a tip for you: do not go on write something like this. It's completely unnecessary. You can write really complex equations in C. Just do not write them. That's it. Make something that is readable. Even if you want to write something, do not write something like this, like minus 3 plus minus 2. No, don't do it. Put some bracket in front to make it even more clear for the reader. This will not harm your performance, believe me. It will not harm your performance, but make it more readable for the reader. Okay.
Okay, sir.
So like even for minus one, my plus j divided by minus k. Before going to this, let us take a look at this. We have covered these things today in the class. We have covered these things during the class: unary plus, unary minus, multiplicative, and additive operators. So we'll take a look at assignment operators and these increment operators in the next class. Unary plus, unary minus, additive. So these are the precedences. This has one has highest precedence, 5 has lowest precedence. So same way, first the and anything that are on the same level, like u plus, u minus, have precedence too. It's same for all of them, so they have the same precedence. It's not like u plus has more precedence than u minus. In this table, sorry, u plus and u minus has the same precedence. All the multiplicative operators have the same precedence. All the additive operators have the same precedence. So how do we deal if we face two operators with the same precedence? How do we determine which one to evaluate first? That's where associativity comes, and we'll take a look at it. So anyways, so these are the precedents. Unary operators will be evaluated before binary arithmetic operators. So minus I plus j divided by minus k. So we will group these two first together, minus I and minus k. So yeah, these are the first brackets, minus I. Then division has priority over addition, right? Division, multiplication. These multiplicative operators has priority over additive operators. So these will be grouped first, and then the whole thing will be evaluated. First minus k and minus I will be evaluated. Then this thing will be evaluated. Finally, the whole thing will be calculated. And this is the table. And this is very important. Try to at least memorize this table. There is a large table. I have provided a link to it later of all the operators in C, precedence and associativity. You can take a look at it if you want. I will suggest you take a look at it. Okay, anyways, so we now need to deal with operators that have the same precedence. Like in C, if we write something like this, 3 divided by 5 into 2. Like something that you face, right? 3 divided by 2 into 2. Or no, let's write 3.0 divided by 2.0 into 2.0. So what's the result of this equation? Can anyone tell me?
3, sir.
3.
Is it 3 or is it 0? Is it 3.0? Okay, that's fine. 3.0 is accurate, but yeah, 3 saying that is 3 for now, it will be fine. So is it 3 or is it 4.5? Sorry, 0.75, not 4.5. I mean, do I do like calculation like this? 2 into 2 is 4. 3 divided by 4 is say 0.75. So is it 0.75 or 3 divided by 2? If you group this first, I mean, there are like two ways we can group this, right? We can group it like this, or we can group it like this. And this one will be 3. And this one will be 0.75. So you're saying, all of you are saying that this one is correct, right?
Yes, sir.
Yes, sir.
Let's just
sir.
So what's the result now?
3, sir.
3.0, sir.
3.0.
0.
Is you're saying that is 3.0, right? So
Yes, sir.
Yes, sir.
why is it 3.0? So you did it like this: 3 into 2 is 6. 6 divided by 2 is 3.0, right?
Yes, sir.
Yes, sir. No, sir. No, sir. 2.0 is fast calculated.
So you are saying that these two will be calculated first.
Yes,
No, sir. I think
No, sir.
multiplication will be worked first here, sir.
Okay, and why is that?
So according to
Sir,
the
because it's on the
division
left.
will
It's on the left.
Okay, there are a lot of noises here. Okay, anyways, all of you will be making noises, but I will show you two options, and when I say the name of the options, you will shout as much as you can. It's fine. Shouting is fine. Okay. Though the result of both of them will be similar, but I want to know how will they be grouped. Is it like this, or let's say this is option A and this one is option B. All of those who are in favor of option A shout.
Yes,
Option A.
Yes, sir.
Yes, sir.
Okay. And all of those who are in favor of option B, please shout.
Yes, sir.
Option B.
Okay, so I think all of those who are actual option A is right. Let me explain why. In mathematics, we generally do division before multiplication. However, actual division and multiplication are same things. We can represent them using multiplication as well, just by making it like 1 by that number. Anyways, so according to the table, division and multiplication has the same precedence. So what we did actually, since they have same precedence, we group them from left to right. The left things are just like reading the number. We read the first two number from left, group them together, and then we divided by 2.0. So left things are done first, then the ones in the right, and if something even more has are in the right side, we'll group them together. Then we'll do this type of number and do the rest. So we have read from left to right. This is called left associativity. Multiplication, division, these type of operators, plus minus, addition, I mean like binary plus, binary minus, these type of operators are left associative. They read from left to right. So in case of the expressions where there are operators with same precedence, we read according to the associativity. Since multiplication, addition are left associative, we read from left to right. However, like if I ask you to evaluate some value like this, -1, put a plus before it, and put, okay, instead of doing plus minus like this, -1, minus, then another plus, then another minus. Generally, how do we evaluate it? We do not go on evaluate it, okay, minus plus is minus, then minus is plus, and then another plus is minus, and then minus, another minus is plus. No, that's not how it works. We grow from the right side, right? We'll group it like this. Okay, so this one is actually -1, and then we put the plus sign in front of -1. It means this is a unary plus, it's +1. Then we put the -1, and then the final one. You see, I have calculated it from right to left, right?
Yes, sir.
Okay, so these type of things are called right associative things. They are calculated from right to left, like this, right to left. And these one are left associative. They are like this. The right associative is a left associative. So yeah, left to right is left associative. Binary plus minus, multiplication and division. If I write just plus and minus, think of them as binary plus minus. If I write u plus u minus, think of them as unary plus minus. So these are left associative, right? From left to right we go. And unary plus, unary minus are right associative, just like this. So yeah, you need to write a really huge complex equation for some kind of thing. What do you do? Do you go on with the table and try to figure out the simplest way without brackets how you can do that? No, you just use plenty of parentheses. Nobody remembers a table as large as the actual table, not this one. There's a huge table that you will see in tomorrow's class, inshallah. So nobody does that. Just put as much bracket as to make it clearly understandable, and you'll be fine. So if I want to say something like this, okay, -1 into like, I mean, if I want to write something like this, minus b plus square root of b square minus 4 into a into c. I can write divided by, but I should put a bracket here to make it clearly understandable. Divided by. Also, I can put a bracket here. I should, because if I write it something, okay, that will not work. Divided by 2, I said. So yeah, group them beautifully using brackets. If I am unsure about how this will be treated, I can also put a bracket like this to make it even more clearly understandable. Also, it's not necessary to use these brackets between operators and variables or constants, but we put this to make the equation more clear. So yeah, just by using brackets, this is fine. And I have something called bracket coloring. It's helpful. So it colors the different brackets that are grouped together. So yeah. So that's how you should go and write it. Use multiple lines, and some of you actually broke down the equation is also fine. Like if I think that okay, this equation will be too much for me, even for me to understand, even in this form, it's fine to like it shouldn't be. It should be fixed. Writing some. And then I can go on like I'm not writing C code here. I'm just writing things here. New divided by 0. And then I can go and write something like this. I have broken down the whole equation into multiple parts to make it clear to understand. Will you lose performance? You might lose like tiny, not even understandable amount of performance, and in most cases you will actually not lose performance because the compiler will optimize the things for you. So don't worry about writing codes like this. Don't worry about performance at all for now. So try to make your code understandable, and then like after 3 or 4 years you can worry about performance. It's fine. So you can also go on break the equations. Like, can anyone tell me what this equation is? Anyone?
Sir, the discriminant, to find the value of discriminant.
No, that is incorrect. That is incorrect. Minus b root over minus b. Yeah.
To find the value
Solution of
of roots of equation.
So it's the equation of finding the value of x from any.
Root of a quadratic equation. This is one of the roots of a quadratic equation. If I put
Yes,
a
sir.
minus there, that will be the second. Remember, root and quadratic equation. Minus b plus minus root over b square minus 4ac divided by 2ac. So that's the root of a quadratic equation. Anyways, this might be like as epic for you. So remember this equation. Anyways, so yeah, we will cover assignment operators from assignment operator in the next class. So any question from today's class? And from now on, I'll try to cover like less topics but more elaborately in the classes. As I've already said, I need to catch up with some things. That's why the previous week was a bit hectic, but from today I'll try to be thorough and proper with my topics.
Sir,
Yes.
so how does the minus 16 divided by minus 3 operation work? I was actually a bit confused about that.
Okay, so minus 16 divided by minus 3. This one.
Yes, sir.
In integer form or in include form?
Sir, in integer form.
Okay. So instead of directly explaining, let's just see the value first. Minus 3 divided by minus 16. I will not put any bracket for now. So first of all, let us just group it together. Okay. Minus 3. This is a single group, right? Since this is the unary minus operator and it has more precedence than multiplication operator. Unary minus has more precedence than multiplication operator, right? Okay. So minus 3 divided. So this will be grouped together first. This will be grouped together first. Let us check the result first. Is 0, right? Let us just make it minus 16 divided by minus 3 so that you can see the result better. Because generally programming language will not put. It might sometimes put the minus sign before 0, but generally it will not put the minus sign before 0 if there is some. Okay, the value is positive 5. Why? It's simple. When you divide a minus number with a minus number, the value will be positive. So this is completely fine. You do not need to worry about what will be here. The cases that you need to look out for, how they will be rounded, is these. Minus 3 divided by minus 16 divided by 3 or 16 divided by minus 3. Answer can either be minus 5 or minus 6. If I do it, both of them will be same. Both of them will be minus 5. See, this is minus 5, and if I do minus 16 divided by 3, it will be minus 5. Why? Remember the rule. In C99, the result is always truncated towards 0. And if in most of the compilers, if I do not mention in a standard, the standard that is picked is generally C99. There's also C11. Okay.
Yes, sir, I got it.
Minus 16 divided by 3. So it can be like -5. -5 into 3 is -15, and -6 into 3 is -18. So it's either -5 or -6. Which one is closer to 0? -5. So it will be -5. Okay. Any more question? If there's no more question, I will stop today's class here. Stop the recording. And then now I'll take your attendance in the old boring way. Today's date is 7. Please respond to your roll call. Abu Hena Sadid, Shahrir Rashid Khan Sifat,
Present, sir.
Ridwan Hussain, Abu Zawad Muhammad Ridwan Hussain,
Present, sir.
Arafat Hussain Anjar, Asif Tashu Adipto,
Present, sir.
Asif Abrar,
Present, sir.
Asif Mahmoud Fahim,
Yes, sir.
Karim Tasnim Ridi,
Present, sir.
Ahim Abrar.
Present, sir.
Okay, the rule applies. If you have mic problem, just write them in the chat. I will take a look at them later. Chaudhary Blossom Ibn Razak,
Present, sir.
Fardin Fayaz,
Present, sir.
Labi Muntasir,
Present, sir.
Ehsanul Haq,
Present, sir.
Tanvi Chaudhary,
Present, sir.
Aryan Bashir,
Present, sir.
Iftikhar Jaman Ifti,
Present, sir.
Naim Mubashir Munim, Labiba Nawar, Aziz Amin Yasser Alam,
Present, sir.
Awad Ishma Marian,
Present, sir.
Akif Kaiser, Radib bin Kabir,
Present, sir.
Yusuf Ibn Kamal Niloy,
Present, sir.
Miftaul Alam Siam, Mehdi Ahmed,
Present, sir.
Abdullah,
Present, sir.
Mustabashir Ibn Amin,
sir.
Muhtasimul Roha,
Present, sir.
Maruf Ahmed, Samnun Asfar,
Present, sir.
Ramisa Zaman Audhi,
Present, sir.
Benjamin Tabassum,
Present, sir.
Amin Sarkar,
Present, sir.
Hadia Sultana,
Present, sir.
Adman Nahian, Shadman Nahian, Merin Kazim, Sadiq Salman,
Present, sir.
Mustasim Kamal Dihan,
Present, sir.
Mosammad Jannatul Samaruk,
Present, sir.
Mushfiqur Rahman,
Present, sir.
Saima Sidul Muna,
Present, sir.
Sajid Hussain,
Present, sir.
Nahian F. Siddiq, or Siddiq, Tanvir Hossain Dihan,
Present, sir.
Shamia Sarmin Divana,
Present, sir.
Shuaib bin Hassan,
Present, sir.
Zarif Safwan Haq,
Present, sir.
Afon Sabib,
Present, sir.
Sayan Ilham,
Present, sir.
Abim Ahmed,
Present, sir.
Anwar Ahmed Tanmoy,
Present, sir.
Abdir Alam Saad, Tanvir Hassan Ahmed,
Present, sir.
Munzir Mahmoud,
Present, sir.
Amir Arafat, Amir Arafat. I couldn't hear the present of Amir Arafat, so if she's there, you should write in the chat. Arsalan Waqif Shah,
Present, sir.
Abdul Halim Hadaruni, Muktashir, please mute your mic. Is Abdul Halim Hadaruni there? Yeah, I mean it's fine. Right, just write in the tab. Wassa Lutufi Sebanya, your ID?
Present, sir.
Yeah, what's your ID?
It's 156.
What? One?
156.
1556. Okay.
156.
Got it. Were you present in the previous classes?
Yeah.
Are you sure? All the classes?
Yeah.
You were
Yes.
present in. Yes. Okay. What's the Lutufi 7? Okay. Labiba. Arsalan Amina. Just give me a moment. I will call the name of the absent students once more. If any of you are present, just give me present. Arafat Hussein Anjar, Naim Mubashir Munim, Sakif Kaisar, Miftaul Alam Siam, Maruf Ahmed.
Sir, my phone is not present.
Which one?
ID
Miftaul Alam?
24.
Okay,
Yes,
ID 24. Okay, you're present. Okay. Maruf Ahmed, Shadman Nahian, Mehrin Tazin, Nahin F. Siddiqui, Sabir Alam Saad. Okay. We are done with Sakif Kaisar is present. Okay. I am giving the present today, but from the next class, if you do not write within the time the roll calling is done, your presence will not be given. Okay, I think we're done. Nine, I've given yours, and Sakif, I've also given yours. Okay, we're done with today's class. So if any of you do not have any more question left, you can leave the meeting. And yeah, and as also Arsalan, about your question, it depends on the standard. If you're using like C89, then we cannot tell that whether the answer will be -5 or -6. But if we're running it in C99 or any standard after that, like C11 or C17 or the experimental C2X, we'll know the answer that it will be -5. It will be truncated towards.
Yes,
Okay.
sir.
Okay.
Yes, sir. Thank you, sir.
Welcome. So see all of you today in today's lab. Goodbye.